Okay, so what we're going to be doing here is properties of logs, which are a lot like properties of exponents. So just a reminder, these special properties we talked about, common log when it's at 10 is 1. Anything to the 0 power is 1. When it's a base of e, to get a 1, it's again 0 power. And a base of e to itself is 1. So we talked about these. When the number or the answer is 1, the exponent is 0. And when the base and the answer are the same, the exponent's always 1. Now, we've already done the power property, which is similar to the exponents, like we said. The power property is right here, and we talked about using these on equations, is you would bring the power to the front and make it a multiplication problem. So in this case, I would bring the 4 to the front, and if I was to rewrite this expression, and I would write it as 4 times log base 3 of 9. Okay, so we've done this property. The two new ones we're going to talk about today are product and quotient property. Okay? For the product property, it's a lot like the exponents. Product, when you're multiplying two logs, you add them really. They're the same thing as multiplying is adding. So you can see here, if I'm adding 4 times 16, it's the same thing as adding the two logs. In this case, 9 times x, I would split it up and make an addition problem, log base 2 of 9 plus log base 2 of x. Those are equivalent. This multiplication and that addition are the same. Okay? So that's the first property, and we're going to talk about using that. The second one is the quotient property, where just like exponents, you would subtract exponents. So in this case, we're going to be doing is subtracting and splitting up the log, kind of like distributive property. So we're going to rewrite this expression, okay, this quotient, with a subtraction. So we would make log base 2 of x minus log base 2 of 5. And there's your answer. They are equivalent, this and this. This is what's known as condensed form, where it's written as 1 log. This is known as expanded form, where it's written with the property written out. So we're going to be talking about condensed form as 1 log and expanded as 2 logs. So we're going to do a couple different between condense and expand and kind of go through them. So if you take a look here, okay, turn the page. Let's take a look at first when it comes to expanding a log. So expanding a log, again, this is condensed form. It has 1. We want to expand it out into having addition and subtraction. Here's your working backwards. You always want to see if you do the quotient property first, then product, then power. In this case, there's no quotient, there's no fraction bar, but there is a power, product. There is multiplying. So the first thing you're going to do is let's split this up and rewrite it as an addition problem. Log base 8 of 64 plus log base 8 x squared. So we did that product property there. And there, now let's do the power. There's a 2 here. So we're going to rewrite that as bringing it to the... So log base 8 of 64 to log base 8 of x. And there's your answer. You could simplify it further if you wanted, since this is actually a whole number. 8 to what power makes 64, and you get 2. Technically do that, but if you can get to that point at this point, that's fine. Let's take a look at number 3. For number 3, there's no quotient rule. Again, this is condensed form because it's 1 log. There's no quotient property, so meaning no fraction bar. So it's all multiplication. So we have this being multiplied by that being that. So we're going to split this up and write it as an addition problem. ln of 3 plus ln of x plus ln of y to the 3rd. Now, from there, this is where you're going to take the exponent and use the power property as your last one and bring it to the front. So ln 3 plus ln x plus 3 ln y. And there's your answer. This is the expanded form. That's the condensed form. They're equivalent expressions when it comes to logs. That's all there is to it, though. Let's try one with a quotient. If it's a quotient property here, you know what it is because it's a fraction bar. Right away, that's going to be your first step. You're going to keep this the same. We could see it's going to be a product property up here because they're multiplying, but wait. First thing is do the quotient property, which means I'm going to take that and change the fraction bar to subtraction. Always do the quotient property first. Then from there, you're going to take any product, right? Multiplication here, and split this up with addition. Like so. Then your last step to simplify it even further is bring any powers to the front. So ln 3 plus 4 ln y minus 3 ln x. So this is equivalent to this. This is called condensed form for 1 log. This is called the expanded form. Okay, and these are special properties of logs. So now let's talk about what it looks like if it is condensing, right? So let's take a look here. Condensing, you actually go in the opposite order. You want to do the power property first, then the product, then the quotient. To condense, it means you're putting it into 1 log, okay? 1 whole log expression, 1 whole log. So, for instance, if you take a look here, okay, you want to do any powers first. You know there's a power when there's a number or a variable in front of the log. So I'm going to do this first. So log x squared is really what that is. That's really what that is. It's log x squared plus log 5. Then, now you look for, is there a product? Well, yeah, there is a product because in log, the property, when you add logs, it's the same thing as multiplying. So we're going to condense them and write log once, okay? We're going to bring it into 1 log. That's what condense means. And we're going to multiply x squared times 5, so it's 5x squared. Okay? Now, here, first thing, is there any power rules? Yes, the 2's in front, so we're going to take care of that first. So just rewrite it with y to the 2nd power. Now, is there any product? No, because this is 1 term y squared and this is x. There's nothing, and to be honest, and there's no pluses. So if there's no plus sign, you're not doing the product rule. But when you see the when you see the subtraction, think fraction. So again, our goal is to write this as 1 condensed log. I know because there's a subtraction there, it's going to be a fraction bar. So from here, this is going to be the numerator, x, and this is going to be the denominator, y squared. And there's your answer. So again, let's take a look at number 4. Okay? You can see here, there's several power properties. This number in front, that, and that. So we've got to do that first. So go in and do the power property first. Now, after the power property, you see if there's any product. Product being addition. Now, there's not any addition. You see that there are 2 subtraction signs. You can't have a fraction on top of a fraction. It doesn't look right. Now, we're going to have to think distributive property. We're going to want to rewrite this, okay, as the product property. And here's what I mean, because remember, if we were to add parentheses in here and rewrite this expression again, so give it a second and just watch. This here is equivalent to what I just wrote. Imagine if you had a -1 here and you distributed it, they would be equivalent expressions. So you're going to have to find that. You want to take the first subtraction, okay? The first subtraction is going to be where the quotient property starts. Everything else after that, if it's all minuses, are all going to be your denominator through the product property because these are equivalent because of distributive. So copy that. So now what you want to do is, since we're going to be writing as one log, they all have a base of 4, so log base 4, right? We're going to condense them together as one log. Again, this subtraction in a word of logs stands for the quotient, so it's going to be the fraction bar. This would be your numerator on top. And since these two are now with the product property, I'm going to take x to the 5th and multiply it by y to the 3rd, and it's going to be at the denominator. And this is my condensed logarithmic expression. So these could be a little tricky. We are going to review them next class, and all I'm asking for your homework is to try your best on it and practicing doing these basic rules, and we'll get more in depth with them next class on Friday. But for now, you're going to put this away and nothing on your desk, not even a calculator. We're going to start with the no calculator quiz. Then you finish that, you'll turn that in, you'll get your calculator quiz. Finish that, you can start the homework sheet. Good luck.